Okay, so in 5.1, which is what we covered on Tuesday, we talked a little bit about that normal curve, that bell-shaped curve, and the fact that if it's been standardized, kind of like how they standardize scores on an ACT or an SAT test, then they are able to take whatever the data is, and they're going to say the mean is 0. We call that a Z value, that the mean is 0. And a standard deviation is, do you remember how many units? When it's been standardized, it's just 1. Very good. So the mean is 0, the standard deviation is 1. And we said, because in those standard curves, you've pretty much got all of the data when you get how many standard deviations away from the mean. You remember back with the empirical rule? 3. Okay, at 3 standard deviations, we know typically we've got about 99.7% of the data. That's not 100%, but it's pretty darn close. So what we're going to look at is, as we try to standardize this data, what you will find is, if looking at one of those tables that's going to be a Z chart, typically it'll go to about negative 3.5 or so to the left of your mean, and it'll go to about positive 3.5 on the right. If we're going to use the TI calculators to find our probability distribution for a normal CDF, we said that the calculator kind of defaults to way, way, way out. And it actually gives us a little more accurate reading, because everything in that table that we're provided in the textbook has been rounded 4 places to the right of the decimal. So let's look at what happens when our data doesn't come to us in the form of a Z-score, but it's that raw value from something out in the real world. So let me see if I can get this thing going. Okay, so look at this. You've got a normal curve, and it says if it's normally distributed, you can find the probability that X is going to fall in a given interval by calculating the area under the normal curve for that interval. And remember, probability is going to be cumulative. It's everything below that up to that value. So if we wanted to find the probability that X was less than 600, and we knew the mean was 500, and we knew the standard deviation is 100, that's our raw data, right? It's not a Z-score. It's not been standardized, but it's raw data. So here's what we could do. We can take it and turn it into a Z-score by taking the X value minus the mean, and just so I can be sure you're seeing what I want you to see here, that means right here is our formula, okay? So our X value came from here. The mean is something we were given, and then you divide by the standard deviation. So 600 minus 500 is 100, and 100 divided by 100 is 1. That just turned this probability that used an X value into something that's been standardized that uses a Z value. Now, if you're going to use that table that has Z-scores, you have to do this. If you're going to use the TI calculator, you don't necessarily have to do this. So I'm going to show you that in just a minute. Okay? All right. And if at any point, if you guys have questions, ask me. Okay, so this says a survey indicates people use their cell phones an average of 1.5 years before buying a new one. Okay, do you guys usually keep your cell phones longer than 1.5 years or not? I'm curious.
I keep mine longer than that.
Mine's like 2 years right now, and I'm still using it. So.
Okay. Word of warning, I was not interested in spending the money on a new phone, and I kept one about 4.5 years. I did change the battery at some point in there, and one day it just died. I mean, wouldn't boot up at all. Took it to the AT&T store. They couldn't recover any of my stuff. I lost everything. So be
What brand
careful.
was it?
Well, it was an iPhone.
Exactly. There you go. Case closed.
Oh, okay. Well, if you're an Android person, then maybe you don't have to worry about it. So heads up, just be careful you don't lose all, make sure you back up all your stuff somewhere, because I had not backed up in a long time. That was sad. So let's look at this. You've got 1.5 years as the average length of time people have their phone before buying a new one. Standard deviation is 0.25 years. You select a cell phone user at random. You want to find the probability that the user will use their current phone for less than a year before they buy a new one. Okay, and we're going to assume that the variable X is normally distributed. Is it important that we know it is normally distributed?
Yes.
It is, because if we don't know that it's a normal distribution, then we can't use any of what we're talking about here. So if I were to sketch this out, here's how I would put my data on here. My mean is how much? What did it say was the mean time somebody keeps the cell phone?
1.5.
1.5. And what is the standard deviation?
0.25.
0.25. And it asked me to find the probability that somebody would keep their phone for less than a year. Now, if I'm looking at this, and right here is my mean, I know 50% of the data is to the left, 50% of the data is to the right, and that mean is 1.5. What is the X value that I'm supposed to be using? I want to find the probability that X is what?
1 or no?
Exactly
Less than
1 or
less than 1.
less than 1. Very good. You'll have to pay close attention to how it's worded. It could have said that they'll keep their phone for more than a year, and then we'd be looking at something to the right of 1. But since it's less than 1, I know somewhere over here is 1, and that means I'm trying to get this area, everything to the left of 1. Okay, now if I set it up as a Z-score, how would I plug in? Do you remember what the formula is?
No, like 1 point.
X minus the mean over the standard deviation. So go ahead and tell me how you'd put the numbers in. It would be what for X?
1.
1 minus
1.5.
and divide that by
0.25.
0.25. Okay, so here's what I'm going to do. I'm going to pull up, well, actually, I'm just going to take this calculator because this is just crunching numbers. So 1 minus 1.5, and I'm going to divide that by 0.25. Hopefully you guys are doing that as well. What did you come up with for a Z-score? I got -2. Anybody else get that? When I crunch those numbers, I get -2. Now, what that tells me is if this thing was standardized, same bell-shaped curve, but I set the mean to be 0 and the standard deviation to be 1, then I'm actually over here at -2, and I want the area to the left of -2. That's my standardized curve. Okay, this one, I just stuck 1 on somewhere. I've got probably too much area over here with 1 on this one. But it's the same basic shape. I've just been able to label it where it's standardized. Now, let me show you real quickly. I'm going to clear this out. Remember, we came up with a Z-score of -2. And there's our curve. And what they did is they looked in the table and they came up with a Z-score of -2 tells you that 0.0228 is the area to the left of a Z-score of -2. Now, if I turn that into a percent, that's 2.28%. That's an unusual event, isn't it? Because
Yes.
what's the cutoff for being unusual?
5%.
5%. Okay, so that's out, and we kind of know that. If you go back to the empirical rule, if I'm 2 standard deviations away, I know that 95% of the data is 2 standard deviations away. So I would expect this to be about 2.5% in that one tail, because I'm just on one side of where that 2 standard deviations is. I'm just on the low end. So that's one way you could do it. Now I want to show you something else. Okay. And do you see the TI calculator or not?
No.
Okay, so let me share that. Okay, so I've got it up now. And see if you can remember where we said you could go in the calculator if you wanted to do a normal CDF.
Was this last time we were here?
It was the last time we were here. So that was second bars, right? And there it is, number 2, normal CDF. Now, this part is kind of cool. All right, remember I said for the low end, as long as I'm in that tail on the left side, I'm just going to put some really small number, like I'm gonna type in -1,000,000. I'm just going to put that. Okay. If you put -10, you're probably good. I'm just going to put a big negative number there. Now, we wanted to go up to what X value? 1, right? Because we were getting the probability that X was less than 1. Now, if we're using the raw data, it's not been standardized, so it's not a Z-score. What did they tell us was the mean on this data?
1.5, wasn't it?
1.5. And what did they tell us was the standard deviation?
0.25.
0.25. I can put all that in. Is that the same thing we just got on the other screen? 0.0228 is how that would round. So you don't necessarily have to convert it to the Z-score if you're using the TI calculator. It can take the raw data, and by telling it what's the mean and what's the standard deviation, it'll take care of it for you. Okay? Either way is fine. You can change it to the Z-score, look on the table if you need to, or you can do it this way. All right, questions so far, we good?
Mm-hmm.
Okay, so let's go back to the PowerPoint. And let's look at another one. A survey indicates that for each trip to the supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store. So the length of time spent in the store is normally distributed and is represented by the variable X. Shopper comes in the store, find the probability the shopper would be there between 24 and 54 minutes. Now, heads up, if this is a test question, here's what I'm going to look for on your paper. Did you see the word normally distributed?
I don't think so. Oh, no, I did. Yeah,
You did.
In the middle.
Okay, so here's what that tells me. I'm going to expect you to draw a standard normal curve for me. It does not have to be pretty. It just has to be an effort, okay? And what did they tell me? If you're going to use the TI calculator, you don't have to change to the Z-scores, so you could actually put these X values on here if you want. If you're going to use the Z-scores, then you would need to come over here and show me how you changed it to the Z-score. Okay, and then on this drawing, you would put the Z values. If you're going to leave it as X values, then what should you tell me is the mean? What does it say on this problem?
45 minutes, I think.
45 minutes, good. What does it say is the standard deviation?
12 minutes.
12 minutes. And what is it asking me to find? The probability of what?
Between 24 and 54 minutes.
Okay, very good. So I want to know that somebody's in the store for between 24 and 54 minutes. So if this is 45, I know 24 is over here somewhere.
So are we assuming this is inclusive?
Yes. On these, you will assume that they are inclusive. Okay, and so that's the area that we're looking for. Now, if I were to ask you guys, what is your preferred method of doing this? Do you want to use the Z-scores, or do you want to leave them as X's and find them in the calculator? What would you do? Y'all give me some feedback so I know what you're thinking.
Until I actually do it, I really don't know.
Okay, so I get that, Troy. What about Sydney and Abigail? What do y'all say? Are you more interested in the calculator, or are you more interested in doing it by hand?
I was just doing the calculator.
Okay.
Yeah, I'd do the calculator.
Okay, so if you have the download for the free TI software, you can do it that way for now until you get the calculator from Ms. Putman. And so what you probably want to do is make sure you take some notes, or you use that sheet I gave you that explains where you go to do this. So I want to volunteer to tell me how you would go from this information we just put down on this problem into the calculator, what buttons you're going to press to come up with the answer. Who wants to do that?
Like second bars.
Okay,
Like
hang on a second. Let me get the calculator up. Okay, and you said second vars, then what? Somebody help Troy out. Don't leave him hanging.
Is it TPDF?
What do y'all think? Seth, do you know? What are we looking for?
I think CDF, normal CDF.
Normal CDF. Thank you, JT. So it's a normal CDF that we want. Now, on this one, did we shade area that was all the way out in the tail, or did this have like a starting point and a stopping point on our graph?
Starting points and stopping
Exactly.
point.
So what was our lower bound according to this
24.
problem? It was 24. And our upper bound was
54.
54. Now, do you remember the mean on this problem?
45.
It was 45, and the standard deviation was
12.
12. This is all in minutes, by the way. So it pasted it in. And what would you say is the probability somebody is going to spend between 24 and 54 minutes in the store?
73%.
If we were listing it as a percent, that's what we would say. If you're pulling this out of the table or out of the calculator, you want to go 4 places to the right. So you're going to put a probability that X is between 24 and 54 is 0.7333. And that would be the answer you would provide. Okay? That's all there is to it. Make sense?
Yep.
Okay, so let me clear that. Let's go back to the PowerPoint. Okay, and let's check and see if that's the answer that they came up with. Right there, 0.7333. Now, here's what you see on the screen, and this is why I'm asking which way do you want to do it, especially when you have these starting point, stopping point that you're not in a tail. Look at this. You've got to convert the Z-score to find the left end point. You've got to convert a Z-score to get a right end point. You've got to look up both of those values in the table, because everything to the left of this 0.75 was 0.7734 going all the way out to the tail, but we've got to subtract what's to the left of negative 1.75. To me, it's a lot more work using the table. I like using the calculator, but you can do it either way. Okay? All right, now look at this. If 200 shoppers entered the store, how many shoppers would you expect to be in the store between 24 and 54 minutes? So if I know there's like a 73% chance that's how long somebody's going to stay, and there are 200 shoppers, doesn't it make sense? I just multiply those two together and I get about 147 shoppers. Okay, so you'll have to watch the question to see what it's asking. A lot of times students will overlook a question like this and just give the probability and not actually answer how many people. Also, if you answer 146.66, that's not a good answer when you want to know the number of people. You need to round to the nearest person, okay?
He's missing a one.
That's right. We do not need somebody coming in with half or a third of their body missing. So let's look at what happens if we want to find area to the right. Now, this was asking us, what if you wanted to find the probability that somebody would be in the store more than 39 minutes, okay? So let's say it's greater than 39 minutes, and technically you asked me about assume that it's inclusive. It honestly isn't going to make a difference on this, Troy. We're just going to use the value, and whether you put or equal to or not is not going to make a big difference on, I mean, you're still reading it the same way out of the table or entering it the same way in the calculator. So we said 45 minutes was the mean, and we said the standard deviation was 12, and the question is, what's the probability that they're going to be in there longer than 39 minutes? Well, 39 is to the left of 45. So this is the area that I'm looking for. Am I going to expect to see the normal curve on your paper?
Yes.
Yes. Am I going to expect you to label what you're using for your mean, your standard deviation, and your X value?
Yes.
Yes. And I'm going to expect to see a shaded area, so I know that you knew what you were looking for, okay? And that's going to help me figure out how much partial credit you should get. If you've got the right value, but you shaded the wrong region, you messed up on the inequality. Or if you pull out, like if you were looking in the table, or if you're using the cumulative CDF, you might stop a little bit too soon on this problem. So I want us to go to the calculator. This is a normal CDF question, correct?
Mm.
Okay, so if I pull up the calculator and we type in second vars, choose 2 for normal CDF. Think about that graph for a minute, and I'm going to go ahead and put it on the screen just to remind us. We had 45 as the mean. We had a standard deviation of 12. Here's where 39 was, but the area that's shaded is this direction. So what would you put in for your lower bound?
39.
39. Now, what are we going to put in for the upper bound?
A ridiculously high number.
Because we're in the tail, correct?
Indeed.
Indeed. So let me clear that off, type in 39. And that means for the upper bound, instead of putting like a negative million, I'll put a positive 100,000 million, something like that. Now, for the mean, it's still 45. Standard deviation is still 12. That's left over from the last time. And look what we've come up with. We've got 0.69146. So what would you say is the area there, or the probability?
0.6915.
0.6915. Are we all in agreement on that? Because that 6 is going to cause the 4 to round up. Here's the cool thing about the calculator. I can tell it, this is my lower end at 39, and I want to go up to the right tail, and it will give me the area that I need. If I'm using the table, I have to look up a Z-score that goes with this 39. And what it's going to tell me in the Z-score is always area to the left. So it would give me this area, which is actually the area I don't want, but it's the complement of what I do want. So I would have to do 1 minus the probability of whatever I get when I do x is less than 39 in order to get whatever the probability is that x is greater than 39. Does that make sense?
Mhm.
Okay, any questions so far? So just to kind of rehash a little bit, last time we only looked at the z-scores when we were given things that had already been standardized. So we always had a mean of 0, standard deviation of 1, and then we were looking at probabilities for the z-scores. This lesson gives you the raw data, which you can either change to a z-score or you can put it in the calculator and find the data using the x value and the mean and the segment. And there we go, 0.6915 is exactly what Troy said we would round that to. Okay, and we could take that and multiply it by 200 if we wanted to know about how many shoppers we'd expect to stay more than 39 minutes. Okay, here's another question that we could work through this. I have a question for you guys, because we had talked before about you guys watching the videos and we would more or less kind of troubleshoot in the Zoom meetings. So at this point, do you feel like you want to do more of these examples, or do you want to look at some homework problems on this? What do you say?
I'm fine with either.
Okay, so Seth, tell me how you're feeling about this lesson. Do you feel like you know what you're doing, or are you not sure if you'd know how to do this if you had to do it on your own? And you can, if you guys want to, you can either unmute and tell me, or you can send me a message in the chat and tell me if you're good or if you want more practice with the notes. So that means I need to hear from Seth and JT and Abigail and Sydney. Okay, so Seth says maybe do it just a few times. So when you say that,
I think the homework questions.
so you're thinking go into some homework questions to practice that way. Okay, I'm with you on that. I think we
Yes,
might,
ma'am.
yeah, I think we might do that too. So let me pull up some homework. Let me go back here, and I'm going to minimize that, and go, nope, not there, go here, and go to Assignment Manager. Okay, are y'all seeing the my Math Lab screen or not?
Yes.
Okay, just want to make sure that it actually opened, and I'll have to change screens here in a minute. So let me pull up something from 5.2. Okay, and this one is very, very basic. I'm sort of betting that you guys might be more interested in some of these that are set up more like word problems. Am I right? So let's try this one. This one is number 4 that's in the homework. It says, in a recent study on world happiness, and that's an interesting thing to study, people were asked to evaluate their current lives on a scale from 0 to 10, where 0 is the worst possible life, 10 represents the best possible life. I'm thinking this might not be a good time to launch a survey like that. What do you guys think? The responses were normally distributed. That's important for us to know, with a mean of 5.5 and a standard deviation of 2.1. Okay, so we want to find the probability that a randomly selected study participant's response was less than 4. So let's say I've got my normal curve here. There's my mean. And I want to know the probability that somebody's response was less than 4. So if that's 5.5, 4 is over here somewhere, right? And less than means I go to the left. How are we doing with making, feeling, if I were to ask you, do you feel confident you could sketch the graph and label it and get this
Yes.
far on your own? What do you say? Okay, see a thumbs up from Seth. What about the rest of you guys? Sydney, what do you
I
think?
feel good about it.
Feel good about being able to do the curve, okay, and label it. Abigail, how about you?
I'm good.
Okay, and JT and Troy, I think y'all are probably doing well with it too. So we want to find the probability that X is less than 4. So I realize not everybody has the graphing calculator in hand or the app. See if you can just tell me, and this would be the other thing that would probably be good for you to write on your paper if you're going to use the graphing calculator. Tell me what we're going to go find in the calculator.
Like what buttons we're pushing?
Yes, if I were to ask you what buttons you're pushing.
Second vars,
Second vars, and then you go to
NormalCDF.
NormalCDF. So if you wrote down NormalCDF, and then we're going to put in what we would type in the calculator. So what would we put in for that lower value?
We put a really big number, like negative or
There
small
you go,
number technically.
something that is really, really negative. So maybe something like that. What would we put in for the upper bound?
4.
4. What would we put in for the mean?
5.5.
And what would we put in for the standard deviation?
2.1.
So that's what you would type into your calculator, and then it would give us back the answer. Now I'll pull it up real quick so we can calculate it. And if we clear and we go to second vars, choose 2, and type in that big negative number, and then type in 4 and 5.5. And what was that sigma? Do you remember?
1.2.
1.2?
Oh no, 2.1. I'm stupid.
Oh, that's okay. Well, and actually that's kind of a good thing because it lets me show you this. If I go back into second vars and go to 2, it's all there and I can edit real easily. I can just arrow down and change that to 2.1. So that's kind of cool. It'll keep it for you. So that means if we were looking for that probability, remember we go how many places to the right?
4.
4. So you tell me what we should type in on this problem.
0.2375.
Okay, you guys good with that? Let's go to the homework and see if we type in 0.2375, if it tells us that's right. 0.2375. Okay, and then they're going to give us more of these with different boundaries. So this is going to be between 4 and 6. And again, you can go back into that NormalCDF. All you have to edit then would be your lower boundary and your upper boundary. So it really goes fast if you're using the TI calculator on this instead of using the Z-scores in the table. Okay, let's just kind of scroll through and see if we see anything else that looks interesting. Let's find one. Okay, these are all less than questions. I was looking for one that might be a more than. Less than. Well, the C part on this. This says the amount of time per workout that an athlete uses a stair climber is normally distributed. So that tells me I can do my bell curve. The mean is 21 minutes. The standard deviation is 6. And we want to find the probability, and we're going to do C, that the person uses the stair climber for more than 30 minutes. So you tell me, where do I need to put where 30 minutes goes? To the left or the right of the mean?
Right.
because it's a bigger number than 21. So we're going to put 30 right there. And that means, which way do I shade? To the left or the right? To the right, because that's greater than. Okay. So let's go to that calculator. And let's see if you guys can tell me what we would type in on this. And I'm going to clear. So we know we go second vars and we go to NormalCDF. What would need to be the lower on this one?
30.
30. And what would be the upper?
Ridiculously high number.
Something really big. What was our mean? Do you remember?
21.
It was 21. And what was our standard deviation? I think it was 6, wasn't it?
Yeah, 6.
6. So it looks like the answer would be what? 4 places to the right. Point.
0.0668.
Okay, let's try that and see. Okay, so I'd have to put in something bogus for these to get to C, and that's okay. Do the same thing here. Okay, but on C, we said it was, let me take a peek again real fast, 0.0668. Okay, do you see the homework page or not?
Yes.
Okay, 0.0668. There we go. So, are we okay with 5.2, you think?
Yes.
Okay, so I'm thinking you guys, maybe we've practiced that enough. I want to show you 5.3 real quick, and you can go back and watch the video to fill in the blanks. But what we're going to do is basically come at this from the opposite direction. Okay, so in other words, if I give you a probability of something occurring, you're going to have to come up with the Z-score or the X-score that would go with it. Okay, so kind of like how FOIL is going the opposite direction of factoring and vice versa, that's how this works. We're, instead of taking the Z-score and being able to find the probability, we're going to take the probability and go back to what Z-score would have given us that. So, for example, if you've got a graph and you see this curve in the area that's shaded and you know it's 0.3632, how in the world can you figure out what that Z-score should be? Well, here's one way. If you have the table, you can look and scan through all those rows and columns to see if you can find 0.3632. Now, it happens to be here, and that would tell us that the Z-score is a negative 0.3 coming across the row, and the column that goes with it is 0.05, so the Z-score is negative 0.35. That's not terribly difficult, is it? But
No.
what if you had been given 0.3612? Do you see that in the table?
Nope.
Because it jumps from 0.3594 up to 0.3632. There's a lot of numbers that occur between there that I'm not going to see, right? So there are some limitations if you're trying to read it out of the table. Now, if it was something like 0.3612, we would have to decide, is that number closer to 0.3594 or is that number closer to 0.3632? And basically, we would just go with the answer that it's closest to. The one exception to that is if it's exactly in the middle. And if it's exactly in the middle, then we would say negative 0.355, because that would be halfway between the 0.05 and the 0.06. Does that sort of make sense?
Mhm.
Yeah. Now, that's the squirrely part when you're using the table. Since you guys are talking about using the calculator, I think this is going to be even easier. I will mention to you that you got to keep in mind everything you see in the table is area to the left of that value. So if you've got a graph and the shaded region was to the right, before you go to the table to look up your Z value, you're going to need to subtract that from 1 so that you're looking for 0.8925. Okay, and we're actually going to do the same thing in the graphing calculator if we're trying to find the Z-score that would go with that too. So let me show you real quickly. If we did this one, 0.1075 is this blue area. But to get this Z-score, my cumulative area has got to be to the left of that. And that's going to be 0.8925. So far, you guys with me?
Mm-hmm.
Okay, so if I pull up the calculator, here's what I need to do. I'm going to go back to second vars, but instead of normal CDF, I'm going to go to inverse norm. What is the inverse of something? What's the inverse of something? Isn't it typically the opposite? You switch things, right? That's what we're doing here. We're switching by knowing the probability so we can find the Z-score. So here's what I would put in. The area that was under the curve. Now, if I take a peek back at, it was 0.8925, 0.8925. And because it's a Z-score, I'm going to leave the area, the mean is 0, and the standard deviation as 1. Now, this just kind of confirms when I looked at the graph was, and this is new, this is updated. You know what? They have changed this. Let me back up a second, because what this is done, let me go back and just show you this for a second. Okay. If we look at this original graph, this 0.1075 is our shaded region, and it's in which tail, the left or the right?
Right.
The right. If I go back to the calculator, they've updated their operating system from the one that I've had, and so what they are letting you do now is go back and actually put in the area 1075 for the shaded region, and then you can tell the calculator this is actually a right tail graph. That's the area that shows up in the right tail, and you don't even have to subtract it from 1 anymore. How cool is that? And that's going to give you a Z-score of 1.24. Z-scores you round 2 places to the right. So 1.24. Does that make sense? Now, if I go back and I look at that problem, would a Z-score of 1.24 seem logical?
Yeah.
Yeah, because my mean is 0. So 1.24 would be to the right of 0, some. It's not a huge amount to the right, but that's logical, okay? And so if we look at the next slide, look what we came up with, 1.24. So that's really awesome that they've updated that now. Now, depending on how updated the calculator graph, if you don't see that option to choose left, center, right on those calculators the school has, then that means you would need to put in the area to the left, okay, the way I started to do it. And we'll touch base on that when you guys all have those by next class, hopefully. Okay, so on this one, again, if you were asked to find the Z-score that corresponds to, and that P is talking about a percentile. So if this is saying you're in the 5th percentile, what is that area or that probability? If
Oh,
it's the fifth
20%?
percentile, that's 0.05. Okay,
Oh,
5%, change it to a decimal, 0.05. And so that's what you would look up is if I have an area of 0.05, what would be the value that would go with that? Okay, you can also take an X value or take a Z value and change it back to an X value. If you rearrange that formula, remember we had, just a second, we had C was equal to X minus mu divided by sigma. What did they do to come up with this formula that says X equals?
Oh, they just isolate the X.
Exactly. They just rearranged it and solved for X. So you can, it's on your formula sheet. You can use it, or you can just use the Z formula and plug in and then solve for X after you've plugged in all the values. Totally up to you. But I just wanted to point that out, that you do have the ability to take Z scores back to X scores. Okay, so for example, we'll look at this one and then we'll call it done. A vet records the weights of cats treated at a clinic. The weights are normally distributed. Is that important for me to know?
Yes.
Yes, it is. And the mean is 9 pounds, standard deviation is 2 pounds, and we're going to see if we can come up with what the weights would be, the X values that would correspond to Z scores of 1.96, negative 0.44, and 0. So if I use this formula, look what they did here. We're just going to do this the fast way. We're going to plug in 1.96 for the Z score, multiply it by the standard deviation, and then you add that to the mean. That's an almost 13-pound cat. I think that probably is a pretty good size cat. If it had a Z score of negative 0.44, when you plug in, you'd get a cat that's 8.12 pounds. And if the Z score is 0, that means that cat is dead on average, right? It's going to be the mean, 9 pounds. Okay, so that's all you would have to do on that. Do you want to look at any of the homework that's in section 2 at 5.3, or do you feel like you're going to be okay with this?
I'm done.
I know you're probably okay, Troy. What about the rest of you guys?
I'm good.
Okay, so you're good. What about you girls? Abigail, Sydney, do you want to look at anything that's in the homework on 5.3, or do you think you'll be okay with it?
I think I'll be okay.
Okay, so if any of you guys who need those calculators, if y'all might also, you can send a message to Brandon as well to just find out. And I'm going to make sure, Troy, that I get your name on the list too. And then we'll see if he gets in touch with you to let you know where you go or how you pick up. Are y'all going up to the high school periodically to pick up packets and things like that for work?
No.
No? Okay.
Like they gave us one big one and that was it.
Okay. Okay. Well, we'll see, you know, maybe she can get them and set them out on her porch or something and you guys can come by and pick them up. I don't know. But if you run into a problem with that, let me know. She said she'd be able to get them for you. Okay? So Tuesday, we'll review. That means you need to work on the review that's in my math lab. I'll probably bring a few extra problems as well that I'll put on the screen so you can kind of see this is what they'll look like on the test, and we might work through those together. Hopefully everybody will have your calculator by then where we can practice a little bit, okay? All right, well, let me know if you need anything. Y'all take care, and I'll see you next week.
Okay, bye.
Bye.